All right, so this last section for Unit 6 is going over trapezoids and kites. Now, before we get into this actual section, the assignment that you're going to have that goes with this, 6-6, is very heavy on just naming the different shapes. So it goes over a lot of stuff that is not necessarily just trapezoids or just kites. It's more of like, hey, here's this shape. What could I classify this shape as? So before we even get into the notes on this, I'm just going to kind of run down something that's on the notes from 6-2 that I had posted, which is this chart right here. If you want to see this chart when you're doing your assignment, the only place you'll really be able to see it is on the notes from last class, because on the examples for this one, they do give you kind of a chart/table thing, but it's not visual like this one. It's literally like a table with like some definitions and descriptions, which to me is not as helpful because they're usually giving you like a picture or a slight description, and I feel like just having this visual helps a little bit more than the table. If you want to just use the table, cool, but I'm going to kind of explain and break down how the questions are going to go for this assignment using this kind of chart visual here. The first thing you'll need to understand about the assignment, when they're asking you to choose how you could classify a shape, the one thing you have to completely just get out of your head is that on this assignment, you're not just picking one thing, right? On the last one you did, if they gave you this picture right here of a rectangle and they're like, hey, what would be the best description of this shape? Then yeah, you would say a rectangle because it has the 2 parallel sides, it has the 4 right angles, so it's a rectangle, right? The thing is, on this assignment, they're not saying what is the best description. They're actually going to give you check boxes to where you can pick multiple. They're going to say which properties or names could be used to classify this shape, which technically means since rectangle is here, it also falls in the category of being a parallelogram, right? Because it's in that same box. The only requirement for it to be a parallelogram is 2 pairs of parallel sides. Well, a rectangle has 2 pairs of parallel sides. It also means technically it is a trapezoid because a trapezoid has 1 pair of parallel sides. So I would also check that box. And then the most obvious one is if it does have an option for quadrilateral, yes, it's a quadrilateral because quadrilateral is any 4-sided shape. So if the picture they give you is actually a rectangle, then you would actually pick 4 different answers on that. You would pick quadrilateral, trapezoid, parallelogram, rectangle, right? Where most people have been confused is they want to just pick the one because I think in 6-2 you were just picking the one answer, right? Now, the next thing that we want to address, and this was specifically on 6-2, but it kind of ties into this as well. I had a lot of people that were struggling on some of the naming ones on 6-2 because all they were doing was looking at the shape and then saying, oh, okay, this picture looks like a square, so it must be a square, right? They would just give them some real generic shape like this, and they'd be like, oh yeah, that's totally a square. And the only things labeled was something like this, right? And I'm just trying to think of one of the examples that I saw, but this is all that was labeled. And they're like, oh yeah, that's a square. Well, you're right, it does look like a square, right? I mean, literally my little thing drew it. It looks 100% like a square. The problem is, as far as proving that it's a square, for it to be a square, I would have to have something that proves that all 4 sides are equal and something that proves that all 4 angles are 90-degree angles or that they're all equal as well, right? There's nothing on this that I drew that proves that this is a square. The only thing I know 100% sure about that picture that I drew is that it has 4 sides. It has at least 1 pair of parallel sides, so it could be a trapezoid. It actually has 2 pairs of parallel sides, so it's a parallelogram. But none of those other ones in the bottom 3 are proven with what I drew, right? I have nothing on here that shows it has 4 right angles. I have nothing on there that shows that it has 4 congruent sides. So I could care less that this looks like a square if I can't prove it. Right? That's the thing that you really got to train your brain on when you're doing this assignment and even the 6-2 one is stop trying to look at these shapes as far as what you think in your head that they look like. you have to only go based off of what you can prove on the information they gave you, right? So if they draw it like this, that's it. The one thing that I think confused some people is some of them talk about like the diagonals, and it's like, okay, yeah, it has these diagonals, and it tells you that the diagonals are perpendicular, so they make a right angle. If these diagonals are perpendicular, then it's going to be one of these right here. Or sorry, yeah, one of those two right here. Okay, it's a square or a rhombus. Okay, so some people were confused on that. I think that's mentioned in the previous notes, but some people forgot it, I guess, for this one. But that's the big thing. When you're choosing the naming, you're not picking it on what it looks like or what you think it is. You're only picking it based on what you can prove, based on whatever info they gave you. So if they give you a picture and it looks like a rectangle, but all it tells you in the description is there's one pair of parallel sides, well, guess what? That means it's a trapezoid. Even though it doesn't look like a normal looking trapezoid, if all they tell you is, hey, they have one parallel side, then I guess it's just a trapezoid because they only told you that there was one. Okay, so stop basing your answer on what you think it looks like and only base it on what you can prove that it has. That will take care of like quite literally 90% of the assignment, I believe, if I remember correctly from looking at the examples. That said, there are some questions that go over these trapezoids and kites, and that's actually what these notes are for, so I'm going to just run through this pretty quick. So for trapezoid, first thing that we need to go over is a mid-segment. Okay, so a mid-segment is essentially like a line that just goes across, whoops, wrong one. A line that goes across the middle and it connects the two midpoints of this side like that. All right, so that would be a mid-segment. Okay, so a mid-segment is just this line that kind of connects the two middles of these two sides of the trapezoid. And the main thing you need to know about a mid-segment for a trapezoid is that its measure is half the sum of the lengths of the bases. Now that wording might sound confusing, so I'm going to try to simplify it. So if I imagine that this is base number 1 and this is base number 2, that means that when it says the sum of the two bases, that means I would just do base number 1 plus base number 2, and I would write this because this is technically like an equation you're going to use to solve it. But when it says half of the sum of those two bases, you just add the two bases together, and then you just divide by 2. And that's it, right? So when they ask you to find the length of the mid-segment, all you have to do is add those two bases, divide by 2. So if base 1 is 20 and base 2 is 30, you just do 20 plus 30 is 50, half it. Okay, so the mid-segment's 25. Okay, so that's all you're doing is basically finding the average of those two, right? You're finding where's the middle between the two. What else? Oh, the other thing is if it is an isosceles trapezoid, just like an isosceles triangle, isosceles trapezoid just has two sides that are equal in length, which would be the two legs here. So if those two legs are equal, then you know this part here, that the base angles and the diagonals are congruent. Okay, so what that means is, as far as labeling this, if it's an isosceles trapezoid, like this example here, that would mean that these two angles on top are congruent, right? So if one's 150, the other one's 150, even if they didn't label it. And these bottom two angles are congruent. Okay, so if R was 50 degrees, then that means U would also be 50 degrees. Okay, so that's just something that you need to know. If it's isosceles, the top two angles, bottom two angles, they're congruent to one another. Okay. This whole middle section here, we're not really going to go over because it's not anything that's covered on y'all's assignment or on the test, from what I recall. So you're not going to do it. But this is just the distance formula. It's literally just figuring out, how long is this line? How long is this line? If they're the same, it's isosceles. If they're not the same, it's not. Okay. But we're not going into that because we're not doing that. So we're going to skip straight to this exercise part. So for this first question, it just says find each measure, right? So we're just looking for the angle D, which is this one down here. That's the one we're going to solve for. So the one thing I know, like we just mentioned, since this is an isosceles trapezoid, is that this angle and this angle, so A and B, are congruent. So if A is 125, B is 125. Right? So that's just something I know. Because it's isosceles, I know that they're equal. On that same note, that means that angle C and angle D are also equal as well. Right? So they're congruent angles. That is how I can actually go through and solve this, because one thing I do need to know, and you can write this on your notes up here as well, any quadrilateral, okay, doesn't matter if it's a trapezoid, parallelogram, rectangle, square, whatever, any quadrilateral is going to be 360 degrees. So that's something you'll need to know, because there's a few questions on your assignment and stuff where, you know, you're solving for an angle and whatnot, and it's 360. So since I know that it equals 360, that means that all four angles add up to 360. So I could say something like angle A plus B plus C plus D equals 360. Right? That's just saying all four angles add up to 360. Now if I actually plug in the numbers, A was 125, B was 125. For C and D, since they're both equal to each other, I'm just going to put X. So that way I have one variable. Right? So I'm going to say plus X, right? Because they're both the same angle, so I don't have to necessarily put C or D. I can just put X for both because they're both equal. From here, this is just solving equations like you would do in algebra, right? I would combine my like terms, so these two would go together, so that's 250. My two x's go together, so that's 2x, and that still just equals 360. Then I would do, very good, minus 250, which gives me, yep, 2x equals 110, and then just divide by 2, exactly, and you get 55. Okay, so that's kind of how you would do it if you wanted to keep it organized and kind of more algebraic, like you're solving equations. That's the way you would solve it, right? You just say, all right, I know they all add up to 360, plug everything in, and then just solve for x, right? That's fairly simple and straightforward. Another way you can do it, which you do the same thing on this one, because this one, even though they don't label the sides as being equal, they both say 5. So I know these are equal. So again, isosceles trapezoid. That means these two angles are congruent, and these two bottom angles are congruent as well. Okay, on this one, right, since I have 40 in one angle, that means this angle is also 40. All you're really doing in theory is saying, all right, I know this entire trapezoid is 360 degrees. I only need to know angle L, which means if I take out the ones I already know, which is these two 40s, right? So if I get rid of those essentially, so if I say 40 plus 40 equals 80, and I take that out of the entire shape, right? So if I just get rid of it, I know the whole shape is 360, so if I get rid of those two angles, that leaves me with 280 degrees, right? So that's effectively just saying, hey, if I just get rid of those two, all I have left are angle M and L, and that has to be the 280 degrees that's left, right? Well, since they're both equal to each other, I'm essentially just splitting that 280 equally between those two angles. That is why you end up just doing 280 divided by 2, which is 140 degrees. Both of those are the same math. It's just one is kind of solving it more algebraically, kind of really like organized and structured, whereas the other is just doing it in steps, right? So I don't care which way you do it when you're solving those types of questions, but that's essentially all you're doing. You're combining any of the angles you know, get rid of them, and then the two that are left are both equal, so you just divide it by 2, okay? Any questions on that section? No? All right. So let's go. This coordinate geometry part we're not doing, so you can just cross that out. That one's basically just what this example is up here, and we're not doing that. So we can skip down to this bottom part. So on this bottom part, this is where we're doing the mid segments. Okay, so it says if HJ is 32, so if I look on here, HJ is 32, and it says LK is 60, so LK is the bottom base. They want to know what is segment MN, right? So I'm just solving for the mid-segment, like we talked about before. So what you would need to remember, right, which is what I had you write up here, to find that mid-segment, you just add the two bases together and divide by 2. So that's literally all I have to do here. I say, okay, so my two bases, base 1 was 32, base 2 is 60. I just divide that by 2, and that gives me my answer, right? So that's 92 over 2, which is 46. So that's it, right? Mn would be 46, done. Okay, so if they give you the two bases, it's not hard at all. It's literally just type all that in the calculator, add the two numbers, divide by 2, voila, you're done. Okay. Now, where it can be a little different is like in this second one. So in the second one, they say Hj is 18. I'm just going to put this to the side of it, right? So 18 would be the top base up here. But then they tell you Mn, which is actually the mid-segment, is 28. So they tell me the mid-segment is 28, and what they want to know is this base down here, right? So that is essentially my x value, right? So the reason that's different is now I'm not just adding 18 and 28 together, because remember, 28 is my answer. That's what I got when I did all of this, which means I can't just 18 plus 28 divided by 2. That's going to give me a smaller number, right? My second base down there has to be the biggest number out of them all, right? So I know that my equation is base 1, which in this case is 18, plus base 2, which is my unknown number, so I'm just going to put x divided by 2. Well, what does that equal? That equals my mid-segment. Well, I know my mid-segment is 28, right? So that's just writing it all out. In order to solve that, you just do something that you've done a whole bunch of times before. Set it up as a fraction so that way you have two ratios and just cross-multiply them. Okay, it might seem complicated, but once you do that, luckily you're just multiplying that top left part by 1. So it's literally just 18 plus x equals 2 times 28, which is 56. Okay, well, all I have to do from here is get rid of the 18, and then I'm done. So I subtract out 18, x equals 38, done. Okay, so those are really the only two ways you would end up solving that. Either they give you both bases, so you just add them, divide by 2, done. Or they give you one base and and the mid-segment, so then you end up having to solve it like that, where you kind of go more cross-multiply and solve for the missing one. Either way, their math really still isn't that hard. Okay. All right, let's go to the backside now for kites. On this section for kites, honestly, this one really just comes down to knowing like the different properties of a kite. So the first thing is already kind of labeled here for you. So when you're looking at a kite, this is a kite, right? So hopefully that's what you would imagine when you hear someone say a kite, that's what it would look like. The main thing to know about a kite, these two sides here at the top, they're congruent. The two longer tails here, they're also congruent, right? So that's kind of how a kite works. It's all proportionate in that manner. The other two things you need to know are written right here. On a kite, the diagonals are perpendicular. So what does that mean? Just to be clear what the diagonals are, that is these two lines. So the diagonals are perpendicular, right? If they're perpendicular, that just means when they cross each other, they make a 90-degree angle, which technically means all of these angles are 90-degree angles, right? Well, if they're all 90-degree angles, if I was to say, hey, what is the measure of this angle right here, right? Which would be basically just that inside angle there. Even if I don't put a number, I already know, hey, that angle is 90 degrees, right? So if they do ask you, because I think there is a question on your assignment where it's going to just give you a kite and it's going to say, hey, what's this inside angle here? And there's no numbers for you to do any math. It's because you don't need to do any math, right? You're essentially just solving that equation, solving that angle by knowing that it's going to be a right angle on the inside. All right. Yeah, so those are all right angles. The other thing you'll need to know then is this second piece. So in a kite, one pair of opposite angles is congruent. So that might sound complicated. All that means is these two angles here and here are equal. Okay? So in a kite, you have two opposite angles that are equal. These opposite sides are equal, and then the inside angles are all 90 degrees. Okay, so as long as you know those, honestly, the majority of the math you're going to do, if you have to solve anything, is either going to be very easy because you're going to know it, or you will have to do Pythagorean theorem, because effectively, when you draw those diagonals, you just make 4 right triangles in there, right? So that's why you end up doing a lot of like a squared, b squared equals c squared to solve for those, okay? All right, let's do these examples real quick, and then we will be done. So the first one should be fairly easy. It says find the measure of angle JRK. First thing I want to address is a lot of people still don't know how to like tell me what is angle JRK. I've had a ton of people that when I ask them, hey, where's angle JRK? They just do something like this. They say, yeah, it's like here. And then when I ask them which angle is that, they're like, well, I don't know. It's just like somewhere in here. Or they think it's like the whole triangle. Okay? When they say JRK, the main thing you're focusing on is the middle letter, right? So R is the middle letter. When they say JRK, that just means you start at J, you go to R, right? And then from R, you go to K. The angle they're talking about is this one right here. Okay? So JRK is just the point that connects J and K together, which is at angle R. Okay? So that's the angle they're talking about. Well, there's no numbers here. So how am I supposed to know what that measure of that angle is? What is the measure of angle JRK? It's 90, right? We already discussed before all those inside angles are 90. So even though there's no numbers here, I should already know right off the bat this is a 90-degree angle, right? Just because of the fact that I know that they're perpendicular. So I don't have to do any math here. I just have to know, okay, cool. Inside, it's a 90-degree angle. Done. Now, for number 2, I do have to do some math. So it says RJ is 3, so that would be here. And it says RK is 10. And they want to know what is JK. So JK is this outside one. Well, since that's a 90-degree angle, which I'm going to fix this now and make this look more like a box in the corner. Since that's a 90-degree angle, how do you think I could solve for JK? Nope, can't do 90 minus 10. 90 is the angle. I need to solve for this side. So how could I solve for that side? Since it's a right triangle. How do I solve for a missing side on a right triangle? Yeah, it's literally right there. You just do the Pythagorean theorem. A squared plus B squared equals C squared. Right? So all I have to do to solve that question is 3 squared plus 10 squared equals C squared. Right? And then from there I just solve it like I normally would. So that would turn into 9 plus 100 equals C squared, which means that that's 109 equals C squared. When I square root those two, my answer is literally just square root of 109 for C. That's it. Okay? There's no simplifying that or anything, so that's it. So, a lot of the times when you solve for missing sides on a kite, it's just going to be A squared plus B squared equals C squared. Okay, 9 times out of 10, because it's a bunch of right triangles in there. All right. Then this next one, if the measure of angle GHJ, so GHJ is this angle up here. I'm going to use a different color, so let's do this one. Okay, so GHJ is 90, so that's a 90-degree angle, so let's fix that, make it 90. And then GKJ is 110, so GKJ is this angle down here, so they say this is 110 degrees. They want to know what is the measure of HGK. So HGK would be this angle right here. Okay, well if I remember anything about that angle from my model up here, that means that that angle is also the same as this one. That's on the opposite side, right? Those two angles are equal to each other. Since they're equal to each other, you solve this almost the same way that we solved the trapezoid one, right? I know since there's 4 sides to this shape, we've got H, we've got G, whoops, H plus G plus K plus J equals 360. Okay, I know since it's 4 sides, it's 360 degrees. If I substitute the numbers they already told me, I know angle H is 90. G, I'm just going to call that X for now. K is 110. J is also X because they're both the same. So I can put X for both of them. And that equals 360. That is just solving an equation just like you would do in algebra. Right? Combine my like terms, so that's 200. Combine those, that's 2x equals 360. Then I subtract 200, which gives me 2x equals 160, and I divide by 2. So x equals 80. That's it. Okay? So all you're doing is just like with the trapezoid, you're basically saying, all right, well, I need to know what that HGK is. So I basically need to get rid of all the ones I know. Well, I know that's 90. Get rid of that. That's why we subtracted it. I know that's 110. Get rid of that. That's why we subtracted it. Both of these are the same, which is why once I get rid of those 2 angles, whatever's left, I just split it in half evenly because those 2 angles are identical, and that's where I end up with 80. Okay? So my answer is 80 degrees. Okay, this last one should be relatively easy. It says if HJ is 7, find HG. Well, HJ is right here. So if that's 7, what is this side over here? It's also 7. They're literally identical. They're congruent sides. So my answer is just 7. And that's it.